Realize that all matter is merely energy condensed to a slow vibration, that we are all one consciousness experiencing itself subjectively. There is no such thing as death. Life is only a dream, and we're the imagination of ourselves.
So let's say they've given you the following polynomial. It's a function. It's h of x is equal to this huge thing here. Now, we can't use any of the other polynomial techniques that we've used before to factor this right now, because that's x to the power 4. It's not in form of a trinomial. It's not in form of a, where we can use the quadratic formula or simple trinomial factoring or complex trinomial factoring. And it's definitely not the difference of two things, right? So we're stuck. We can't factor it unless we decide to factor it with synthetic division, which is what we're going to have to do. Now, as we stated before, the possible factors that we can do manually, right? There could be other factors. It's just the factors that we can do manually using synthetic division. The other factors, we're going to have to use, computer graphing technique or some kind of algorithm trying to, figure out what the factors are if they're not part of, natural numbers or the real number set that we're talking about, right? Now, the first numbers we're going to try out are the smallest possible factors, right? Now, the possible factors of 60, there's a whole bunch of them. It starts, plus or minus 1, plus or minus 2, plus or minus 4, and it continues on from there all the way up to plus or minus 60, right? For 2, the possible factors of 2 are plus or minus 1 and plus or minus 2, right? So, if we can't find any factors using the possible factors of 60 straight out, then we're going to have to start dividing the possible factors of 60 by 2. Now, there's a whole bunch of numbers there. We're not going to start off with plus or minus 60, right? Because that's going to be crazy. You always start off with the smallest number. You always start off with plus or minus 1 or plus or minus 2. Sometimes, the more of this you do, you can sort of see through the coefficient what's going to work. If all the coefficients, there's tricks to this, right? If all the coefficients are positive, then a positive factor is not going to work because it's not going to kill any of the coefficients. So you're going to try the negative factors first, right? So let's try one of these things out. Try one of the factors out first, and we're going to lay down the synthetic long division right here and just do it right here, okay? And keep in mind, one thing we did mention, if you had any gaps in the descending powers, you would have to put a place marker there, 0 there, right? Right now, we don't have any gaps. All the x's are descending, and there's no skips from, x to the power 4 to x to the power 2. It's all descending in order. So we don't have to put any 0 place markers, okay? So let's lay down the synthetic division form right now and just go ahead and do it and see what we end up with. So the first number that we're going to try out to see if it's a possible factor of this thing is x is equal to 1, which means the factor is x minus 1, right? Remember, the 1 always comes over when we're going to finally write it in the factored form. So we're going to try out 1. So what's going to happen is the 5 is going to come, or the 2 is going to come down, right? The 2 is going to come down, we're going to multiply by 1, it's going to come up here, and then add those two guys, and then come up this way and continue this way. Now, right off, looking at this, I know this doesn't work. One reason is because I set up the problem. The other reason is, I'm multiplying by 1, that's a negative, right? So that's negative 29 minus 5, that's going to be negative 34. And that's not going to add up to 60 for us to take it out, right? So what we can do right now is do this, or change the number to 2 and see if 2 works out in this. Let's do the 1 first, where we're going to see that it doesn't end up being 0. And then we're going to go ahead and, try the other numbers. And the odds are, after this one, we're not going to continue to try all random ones, right? We're going to try one that is a factor, right? Now, I picked one that was really large, and, the factors didn't start off with the first numbers down here, right? And that becomes a real pain on a test or an exam that if you end up writing, because you're going to have to try these smaller guys first before you get to a possible factor of the bigger guys, right? Now, in general, if you're writing an exam, if they give you questions like this, they're going to give you ones where the possible factors are the first couple of terms, and that reduces it down to a level where you can use the other factoring techniques, okay? So keep this in mind. They're not all going to be, crazy things like this, okay? So let's go ahead and do the synthetic long division so you know how it works out, and then we'll go ahead and actually do the factors and then reduce it down from there. So the 2 comes down, you multiply by the 1, 1 times 2 is 2, and you add these guys, you get 4. 4, 1 times 4, that goes up there, and you add those guys, and whatever the result is comes down here. And then from here, you go across, come down again, go across, come down again. So I'm just going to go ahead and do all those, okay? One multiplies to 4, 4 comes up here, add them together, you get negative 25. Negative 25 goes up there, multiplies by 1, it's just negative 25. Negative 25 plus negative 5 is negative 30. Negative 30 times 1 is negative 30. Add them together, you get 30. So the remainder is not 0, so we know x minus 1 is not a factor of the top polynomial. What this does mean is if you put in x is equal to 1 in the polynomial, right, so it becomes 2, 1 to the power of 4 plus 2, 1 to the power of 3, if you do all this, your h of 1, your y, when x is equal to 1, is going to be 30. So this is really a coordinate that we just found for the polynomial. So what we just found out was h of 1 is equal to 30. When x is 1, the y is 30. It's a coordinate on this graph. It's not what we're looking for. We're looking for factors of this guy, right? So what we're going to do, what we have to do now is go back to the beginning, go back to these guys again, the coefficients, write them out again, right? And then try another possible factor of 60. And we're going to do that right down here, okay? So we're just going to move down and try another number to see if it goes into this, okay? Now, one thing you should be careful of is make sure you copy down the coefficients correctly when you transfer them over, okay? Some people end up making a mistake here. And, again, always remember, the sign in front of the number always goes with the number. The other thing you should be careful of is don't draw your line there. Make sure you leave enough room for your workspace, okay? So it comes down and just leave enough room to be able to transfer the numbers when you multiply them up and, add them together. Now what we could do is try one of the other factors of 60 and see if that works out. So we could try x is equal to negative 1, we could try x is equal to positive 2, negative 2, those don't work out, and then continue from there and see which ones work out, just sequentially eliminating the ones that don't. And as soon as we hit one, our life becomes easier because all of a sudden this polynomial is no longer x to the power of 4. The bottom answer is x to the power of 3, so we reduced it down one level, right? Now, we're not going to sequentially go, start from the bottom and start eliminating the ones that aren't factors of this, because I set up this problem and I already know what the factors of this are. So what we're going to do is do x is equal to 3. So x minus 3 being a possible factor of this guy. And I know that one's going to work out, so we're just going to do that one and then reduce it down one level and then use synthetic division for this guy. Okay. So the 2 comes straight down. 2 times 3 is going to be 6. 6 comes up here. Add these two guys. 2 plus 6 is going to be 8, and then so on and so forth. We got down to here. 2 comes down. 6. 6 plus 2 is 8. 8 times 3 is going to be 24. So 24 goes up here. 24, my negative 29 plus 24 is going to be negative 5. Alright, so we got negative 29 plus 24 is going to be negative 5. Negative 5 times 3 is going to be negative 15. Negative 15 plus negative 5 is going to be negative 20. Negative 20 times 3 is going to be negative 60. Negative 60 plus 60 is going to be 0. Papa, this guy is a factor of our original polynomial. So x minus 3 is a factor of the original polynomial. And our original polynomial started off with x to the power of 4, right? So we just divided out an x term from a polynomial that's x to the power of 4. That means our answer down here is now x to the power of 3. So we can write that out. Put in the variables, put in the x's, just so you see what it looks like now. So our polynomial would be 2x cubed, 8x to the power of 2, minus 5x minus 20. So x minus 3 times this guy would give us our original polynomial. And what does x minus 3 being a factor mean? It means when x is equal to 3 in the original polynomial, the y is 0, so it crosses the x-axis as x equals 3. So on the Cartesian coordinate system, we just found one point where the polynomial, our original polynomial, crosses the x-axis. Now, what we've done is, reduced our quotient. This is basically our quotient, right? That's our divisor, that's our dividend, this is our quotient, and that's our remainder, right? We talked a lot about this before. And what we found right now, what we've reduced it down to, is a quotient that's to the power of 3. We can't use any of the other factoring techniques to continue to factor this, right? So what we're going to have to do is use synthetic division on this guy as well to kick it down one level, which brings us down to, if we're able to, sometimes you might not be able to divide this out, right? Maybe this doesn't factor, right? That means from here on, it doesn't cross the x-axis, right? It would mean that this polynomial, or original polynomial, only had one x-intercept if we can't factor this, right? But I know we can factor this because I set up the problem. So what we're going to do is factor this guy using the same technique, synthetic division, to be able to take out one more x from this. That means we would end up with x to the power of 2. That means we can go, back to some more simpler factoring techniques. And continue to factor it and find all the x-intercepts. So if you're going to think about it in polynomial terminology, it's just going to be h of 3 is equal to 0. And we're going to start using a lot terminology like this a lot more later on when we start analyzing functions, right? So this basically means when x is 3, y is 0. It's a coordinate, which is basically 3 and 0. 3 and 0 is a coordinate of the original function, okay, where the original function carries us. So there's multiple ways to express things in mathematics, just like there are multiple words that mean the same thing in different languages, right? There's multiple ways to say the same thing in the language of mathematics, okay? So what we're going to do is copy these coefficients down right now on another wall and use the possible factors of negative 20 divided by possible factors of 2, and we're not going to need to go into fractions right now. We will do one later on where it is fractions, where we're going to have to, multiply out and add out fractions to be able to solve for it. But right now, most likely, cross your fingers, I know it is, it's going to be a possible factor of 20, okay? So let's lay out the coefficients and, continue synthetic division and see where we end up.